Okay, we're good to go.
And welcome everyone to the latest edition of the Ecology Center seminar series. My name is Mark Brunson. For those of you who don't know me, I'm in the Department of Environment and Society as well as the Ecology Center. And it is my very distinct pleasure today to be able to introduce Dr. Jessica Hua, who I've just met but have been a fan of for a while now. And I'll tell you, Jessica is an assistant professor at Binghamton University in upstate New York, where I also was a biology student many, many, many years before she was on the faculty. And one day I was leafing through some alumni material and I found this article that was entitled "Once Upon a Parasite." And I thought, okay, this has got something I got to read. So I looked at it, I found out about, learned a bit about Jessica's work, not only her really cool science, but also the way she was translating it. Some of you know I teach the translational ecology class. It's taught next semester. And so I'm really passionate about us being able to share science with people, with non-scientists, to share scientists with those people we hope will benefit. And so I learned more about Jessica. I read a couple of her papers. I saw her give a video presentation and I said, we really have to bring this person to Logan. So 2020 being what it is, Jessica's not quite here, but she's here in spirit and she's here virtually. And I'm going to shut up now and let her tell us what she'd like to talk about.
Thank you so much for that introduction. I'm so honored to be here, to have this opportunity to share with you all two seminars. In particular today, this is the first time that I've ever had a chance to give an entire seminar on environmental education and communication. So I'm looking forward to this and looking forward to hearing a little bit more about what you all think and about what works for you. So with that in mind, I'd like to start with an agenda to provide a little bit of a roadmap for where I hope to go with this particular seminar. I wanted to start with a little bit of background. I wanted to highlight why and what has shaped my lab group's sort of vision for science communication and education, and why it sort of came into being that it is important in today's world. So I'll start with the background.
Hey, Jessica, just real quick, could you swap your displays? We're seeing your notes too. Perfect. Thank you.
No problem. So after that, I'd like to talk a little bit more about the specific approach. So I'll highlight two examples in particular. First, I'll talk about the art and science work that Mark alluded to before. And then from here, I'll switch over to talking a little bit more about our cure work, or the course-based undergraduate research experiences that we've sort of worked to develop in my lab. So this is the roadmap for today, and I hope to talk for about a little over 30 minutes, which gives us plenty of time for questions, as well as hopefully some discussion on what you all think in terms of what is our role as environmental educators, communicators, and importantly, with all of the things that we are responsible for, what are some strategies that we might be able to take so that we can manage these different roles? So with that, I'll go ahead and jump right into the background. So my lab at Binghamton University, we are interested in understanding how human activity, so global change, influences aquatic ecosystems. So from a research point of view, we ask questions like, how might pollutants or climate change, algal blooms, emerging contaminants of interest like pharmaceuticals, light pollution, microplastics, how do these various pollutants influence aquatic ecosystems? And importantly, how might we think about the ecological and evolutionary consequences of these pollutants? And then from there, how do we take the next step to protecting the environment? So So that's the research side of my lab, and this is something that I'm really excited to share more about tomorrow. I'll show you the link between the research arm and what I'm going to talk about today, which is the idea that in global change biology, this is a field that is directly linked with society. And so when I first started my lab at Binghamton, of course, my focus was on research and communicating research to scientists. But throughout the years, we were realizing more and more, and we were getting more of these opportunities to have to communicate to people beyond scientists, including people in the press, other professions like lawyers, engineers. We were thinking about voters and how we might more clearly communicate to people that can shape policy, and also importantly, the next generation. And so with all of these different opportunities arising, there are a few challenges that came up in my lab group. And these are the challenges that sort of drove our education side of the lab. And some of these things are, we publish our work in peer-reviewed journals, and oftentimes these articles contain jargon that may not be accessible to groups beyond our particular field. And even if we're amazing writers and eliminated jargon from these articles, they're often behind a paywall. So this is just an example. This article in particular would cost somebody $40 to buy and to read. And as we're all well aware, one article on a topic doesn't give you enough information to form an opinion or understanding of that topic. And so I can't imagine how much money somebody would have to spend to get a good understanding of a topic. And then beyond that, we as a lab, none of us were trained in science communication. We didn't really know what the tools were, the best practices for properly telling people about our work. And so with all of this combined, we sort of built upon our research side out of necessity. So asking, in addition to research, how might we also think about ways that we could connect with people beyond scientists? And so thinking about this research education integration as a way to communicate our work to broader audiences. Now, one of the important things about this research education integration is if it is to actually work, we have to think carefully about if we were actually getting to the broader audiences that we were hoping to reach. And so thinking about diversity, equity, and inclusion issues. And this is something that actually was thrust to the forefront most recently. I mean, this is something that we have always thought about in the lab, but due to more recent events, of course, including things like the Black Lives Matter, the increased incidences of violent attacks against Asian Americans, the disproportionate effect of COVID on people of color. All of these negative situations have sort of made us think a lot harder about diversity, equity, and inclusion, and have forced difficult but necessary conversations, at least in our broader society. But relevant to this particular talk and our field, why is it, what might be reasons we might consider diversity, equity, and inclusion in our field, my field of ecology, evolution, and wildlife? And so taking a step back, there are many reasons to care about diversity, equity, inclusion, DEI issues in this field. What I'm talking about today, this is the sort of the information, that the trigger that energized my lab group into action. We work in the field of global change biology, and global change biology has broad influences of human beings on natural environments. And the important point here is that our impact on the environment is heterogeneous. It's variable what type of impact we have, and the variation can depend on a wide range of factors. One factor in particular, highlighted by Dr. Schell and colleagues, is systemic racism. And so they argue in this paper, they highlight in this paper that systemic racism can have cascading consequences on ecological and evolutionary processes. And this is something that we recently discussed in my lab, and I just want to spend one slide quickly showing an example as to one of their arguments. So this is just a figure of two cities One where the green spaces represented in green are distributed throughout, and one where the green spaces are located in one area of the city. And they suggest that because of connectivity, because of the spread of these green spaces, there can be cascading consequences on the abundance and the diversity of organisms in these different locations, as well as the strength and the direction of their interactions. So this is just one example of how a social factor can have cascading ecological or even evolutionary consequences. And so the last thing I want to say about this paper is that they argue and they make a strong case that if we are to understand how factors like systemic racism might affect ecological and evolutionary consequences and processes, we must have representation, strong representation and diversity in our fields of ecology, evolution, and wildlife. With that in mind, we started thinking, well, how does it look in our field currently? So this is just a figure that I generated from data of the US Census as well as data from the NSF. The first column will be US population, and then the two next columns will be the PhDs awarded in STEM and EEB and wildlife. So I'm using PhD as a metric for representation. There are many different metrics. This is just the one that we were interested in, I was interested in as a PhD advisor. So these are the different groups represented in different colors. In the US population, this is what the representation looks like. When we look at PhDs awarded in STEM, what we can see is that there is a decrease in people of color or POC representation. And then when we look even closer at our particular field, EEP and wildlife, this is what we see. And so we can see that there are issues associated with representation in our field, and we can break it down even more to look more closely at what this looks like. So I've highlighted Black and Hispanic and Latino groups. What we can see looking at Latino and Hispanic groups, the orange, it goes from 18% representation in the US down to 5.5. For Black members of the community, even more drastic decrease from 13 to 0.5%. So again, there are challenges with representation in our field. And one point I'd like to make is that when we're thinking about challenges with increasing representation, one of the things to recognize is that there's so much variation in the barriers that might be affecting different groups, right? So one solution does not fit all. And here's just one example. Another example of a people of color are the Asian Pacific Islanders. Here in the general US population, they're 6%. In STEM, actually, Asian Pacific Islanders are overrepresented at 9.8%. Yet, when we look at our field, there is again a decrease in underrepresentation at 3.7%. So what might be these factors that might be causing shifts in interest in these particular fields, or what might be barriers to achieving these higher levels of education? And so looking at the last thing on this figure that I wanted to highlight is that a common misconception with this decrease in representation in our field is that perhaps people of color may not be interested, or this is just not a topic that people would like to pursue or are thinking to pursue. And this is not the case. Increasing research has demonstrated, this is work by Dr. Dorchetta Taylor, and her work is showing that the interest is there. The ability is there in terms of test scores. In fact, in undergraduates, there is representation. It's just at this level that representation goes away. And so all of this put together highlights one of the reasons why we as a lab have worked to think about ways that we can improve our ability to be more inclusive in the field of ecology, evolution, and wildlife. We thought about ways of doing this, and the way that we thought to address this in a structural way was to think about how we might support students throughout their education. So from grades K through 5 all the way to the graduate level, And today in this talk, what I'll do is I'll focus specifically on these two levels for several reasons. For the grades K through 5, there's evidence suggesting that this is a critical age, that once you get kids interested in the environment, this is an age that has sustained interest throughout their lifetimes. At the undergraduate level, this is a targeted area because we are in a position as a research lab to provide opportunities for undergraduates. And there's evidence that these research programs and these experiences help students to understand and know that this is a direction and retention in the field of ecology, evolution, and wildlife. So these are the two areas that we'd like to focus on, or we have focused on. And to put it all together, at this point, we are highlighting our commitment to improving research communication, as well as creating opportunities that can facilitate diversity, equity, and inclusion in our field. So that those stars at the bottom there to remind me to mention that I am trained as an ecologist. We genuinely believe that in order to do transformative research, diversity is fundamental to generating good research. And so that's sort of what has prompted this commitment, but I am in no way an expert in research communication, nor am I an expert in DEI issues. It's just something that my lab is passionate about. So with that in mind and that caveat in mind, today I'm going to switch gears and tell you more specifically what we have done in the lab through two experiences that have worked in the context of Binghamton University and the students here. So I'll start first with our work in art and science. With the art and science work, it sort of started because of my lab's focus on wetland ecosystems. We as a lab recognize the many benefits of wetlands, including several services, including flood protection. This is an image of Binghamton University, at least parts of it after a flood. We've decimated our wetlands around this area. Wetlands play an important role in flood protection, in sequestering pollutants, in recreation, and also supporting a wide range of diversity within the system. Despite these many benefits, we were coming up again and again in community members, just the limited understanding, and they just didn't seem to understand why they should care about wetlands. Here's just one example: drain the swamp, right? The negative connotation of wetlands. And so what this made us realize is that perhaps we weren't doing a good enough job in communicating why wetlands are so important. So this sort of sparked this idea. This is Benjamin McLaughlin. He was an undergraduate student in my lab, and he had the idea of, why don't we try to use art as a tool to improve public perception of research? And so what he decided to do, and what he convinced me to allow him to do with some funding, is to create an art show. And he created an art show with a wide range of his original art, with basically representing some of the research in our lab. He invited members of the university community to come to the art show. And what he did was to assess whether this art show was useful in improving public perception. He conducted a pre-survey and a post-survey. And this ended up reaching the university community, undergraduate students, and there were a total of 188 total participants in these events. So what I'm showing on this figure here, on the x-axis are the various types of questions. I'll break them down into three categories. Knowledge of wetland conservation issue is the first. On the y-axis is just the ranking. In blue, this is before going through the art show. In red, after going through the art show. So in terms of knowledge of wetland issues, there were three questions. We asked them whether they thought they had a strong knowledge of wetlands before and after, whether they thought wetlands were threatened, or whether they thought that chemicals they used would impact wetlands. For the knowledge, this was encouraging to me. After going through the art show, they ranked significantly higher the fact that they had a strong knowledge of wetlands. For the wetlands are threatened, chemicals they use impact wetlands, we actually found that many of the students coming in had a fairly strong understanding that wetlands are threatened and chemicals they used impacted wetlands. So that didn't change much before and after. The next set of questions focused on the impact of wetland degradation. So we asked questions about whether they knew that wetland loss affected plants and animals, whether they knew that wetland loss affected them. And what we found was that they generally knew that wetland loss affected plants and animals, but what was encouraging after going through the art show, that many more of them agreed that wetland loss affected them personally. So they understood that wetland loss affected them. The last category is, well, then if you know it affects them, who's responsible for contributing to wetland conservation? And to look at this, we asked, should the government be responsible? Should you be responsible? And if it's you, how many dollars would you donate per month? So in the beginning, most thought that the government should be responsible, but when we're looking at their personal responsibility, you see that after going through the art show, there's an increase in personal, feeling a sense of personal responsibility to support the protection of wetlands. That's ironic because when we look at the dollars they would donate, there is absolutely no change. And in thinking a little bit more about this, these are undergraduate students, which don't have much fun. Many aren't flowing with the money to begin with. I wanted to actually share a funny comment. On the survey, somebody wrote that they were so moved by the art show. If they had money, they would donate it, but they would donate all their ramen packets to the cause. So I'm thinking a little bit more that perhaps that might be the reason for this particular last set. So altogether, we saw a 32% increase in knowledge of wetland conservation. And to me, this is really exciting because this gave me a reason to continue to pursue this path. As an assistant professor, there's a lot of focus on research. And so this was sort of a risk for us in terms of time and in funding, and this was the push that we needed. So moving forward, we wanted to think a little bit more about moving beyond the university. How could we focus on the local community? And so at this time, we were really fortunate. Roberson Museum and Science Center, they sort of heard about our work with art, and in collaboration with the Schumann Foundation, they ended up giving us some funds to pursue the next step. And so in partnership with Roberson, Binghamton, and SF, we were able to move on to the next phase of this work. We developed an environmental education program. So this was a two-phase program. The first step was to translate the science. How can we use art to translate the science? There were two components to this part. First, we wanted to generate the content. And once the content was generated, we wanted to use this to train educators, to make sure that educators from all different districts would start off on the same level. And then from here, we moved on to implementation. And our goal here was to educate our third graders. And in terms of third graders, again, we wanted to generate content that focused on the third graders because of the research suggesting that this is a critical age for retention of interest in environmental issues. So I'll start first with generating content. We thought a lot about how we could use art effectively. And what we came to was potentially using children's book to communicate information. And so with the children's book, we thought about how we might be able to develop a story about wetland organisms to introduce children to wetlands so that they might understand the benefits of wetlands. And we really wanted to, it was Ben's idea, he really wanted to test this idea that art could be useful. So he wanted the children's book to be about something that typically most people didn't care about. And that ended up being the parasite. And so he chose to write a children's book on parasites because if it worked, it was a clear indication that art would be a good tool. So this is actually how it started. This is my drawing of the concept. I'm not an artist. I honestly don't know what's going on here anymore. I can read two words, the wild and Cercaria. But Ben, to his credit, was able to translate this into something that now looks like this. This is the book Now Gemma Jones Visits Nuthatch Hollow, and it follows Gemma Jones as she meets Talia the trematode. This is the trematode that my lab works on. It has a complex life cycle. If you're interested in the research, I'll be talking all about that tomorrow. But Talia befriends the trematode and follows her through the life cycle. And this book is actually paired with a lesson plan that meets the New York State standards. And the reason we thought this was important was because we really needed teacher buy-in. And so in order to get teacher buy-in, we had to put it in a format that would make it easy for them to use. And so this lesson plan was developed by Vanessa Werthner, my former PhD student who is now with the EPA. I miss her dearly. She was everywhere in terms of the lab. But we generated this content. And a cool thing that Vanessa worked in with the book is Nuthatch Hollow is actually a place in Binghamton. And so the idea is that it would give teachers and students a place to go to get outside, to see the organisms that they read about in the book. But translating the science, we generated the content. The next step was to train our educators. So what we did was we paid teachers to come from 10 different districts. And this 10 different districts was really important to us because in Binghamton in particular, this area, there are huge disparities in the resources available to different districts. And so we thought that in order to increase representation and increase the students that could participate, we would bring teachers in representatives from these different locations. We ran these workshops. We had teachers coming in. They worked through the lesson plans, and we also ran an online course to try to get more teachers involved with the program. After training the educators, we implemented the material, and we basically said to the teachers, here's some incentive. If you use our materials and you teach the students the materials, do a pre-survey and also a post-survey, you'll get a free field trip to Roberson Museum and Science Center. And so we were, thanks to the incredible logistics of this museum, we were able to bus 593 third graders into this program, and they got to interact with, they were working on collecting fake tadpoles. They saw all the organisms live that they saw in the books. And importantly, we were able to sort of assess whether this did it work. And here, these are just some of the quiz questions that we asked. The first three are more general questions about adaptations in wetlands. The last three are about parasites. Again, we were interested in this. In fact, that middle question, are parasites bad? This is driven by an interaction we had with a principal. He actually pulled his class, his entire school, out of our program because he was afraid that parents would be upset that we would teach their kids about parasites because they were bad. And so that's sort of a question we were curious to see if that was just a misconception that was broadly seen. So again, in black here is before and red after. About adaptations, a 29% increase after the program. Whether they could identify a wetland, about a 19% increase. What about what lives in wetlands? We saw a 15% increase. And when we turn to the parasite questions, after going through the program, many of them improved in their ability to identify a parasite. But this is one that I thought was quite striking, 40% increase just with questions regarding are parasites bad? And then I was also very excited to see that after the end of this process, many students could recognize that parasites are an important part of ecosystems. So all in all, there was a 24% increase, and I have to tell you, I was excited, but really relieved. In doing these types of projects, there's a ton of work involved, and you go into it not knowing whether all this effort is worth the time and if it's even gonna make a difference in terms of student gains. And so with this increase, it's exciting to have at least evidence moving forward that at least in our area, art would be a useful tool to continue communicating. Now, moving forward, after working with these groups, we have a framework now that allow us to continue our efforts building strong partnerships. What we like to do and what we're working on now is working with an engineering student, Marumita Gosal. She's working on developing an app, so we're working to target older groups, an app that would allow them to collect data on amphibian calls and dip nets. And what's really fun about this is she sort of developed an augmented reality feature to where, regardless of your environment, you can open up your camera and you can collect amphibians that pop up randomly in your location. We're also working on a card game to teach older students about species interactions, the effect of pollutants. The interactions here are based on some of the studies that are found in my field. But all of this together, I think one of the main benefits is it provides graduate students, undergraduate students with the opportunity to take what they know and translate it into a way that is beyond scientists. So in finding ways to improve communication. So hopefully I've shown you some evidence that art is a useful tool for communicating about wetlands in this particular area. In the last few minutes, I'd like to shift gears to talking about undergraduate research and how we have worked to diversify opportunities for undergraduates in research. So when we think about traditional or undergraduate research models, the traditional approach is that apprenticeship model. So an undergraduate gets to work with a PI or a senior member of the lab to sort of learn the ropes on how to do research. In our field of ecotoxicology in particular, this is really useful because there are an incredible amount of different pollutants that get into the environment. And so this is also an opportunity because it provides a really straightforward way for students to ask authentic research questions and contribute to science. So what do these different pollutants do to host parasite interactions, for instance? And so in allowing undergraduates to take the control of these or take ownership of these questions, they get to go through the entire process from asking the question all the way to publication. And in this way, it's also benefiting them as they move on to the next step in their career. Of those that have worked and have moved on and graduated, all of these students are now in graduate programs or in medical programs. So these are students that have been in my lab. Now, there are many benefits to this type of apprenticeship model. You contribute to the scientific community, but also we get to train the next generation to do science. Many pros, but there are also limits to this apprenticeship model. One of which being you can only reach a certain number of students given time limitation, and also the types of students that are drawn to these opportunities are those that probably would have been successful anyway, so the rising star hypothesis. And so in effort to diversify and to meet the call of many national organizations for increasing graduate research experiences, what we were lucky to fall into was this idea of course-based undergraduate research experiences. I went to a workshop because our department felt it was important to sort of provide more of these opportunities. Course-based undergraduate research experiences are where you have a course designated to complete an entire research project, an authentic research project from question generation to publication in an entire semester. So students enrolled in that class all get that experience. There are many benefits in terms of the scientific direction. The students get experience in the research process, lab techniques, interpretation of results. They get to analyze their data, and they're also able to learn about integrating theory into applied work. In addition to the science gain, they also get to develop broad general skills. So even if they don't want to go into science, they get skills like tolerance for obstacles, independence, collaboration skills, self-confidence, clarification of a career path. And in addition to these skills, I think one of the biggest benefits is that since I've been here at Binghamton, I've been here 5 years, we've been able to teach this 5 times. And that leads to about 95 students getting this experience. And so when it comes to these course-based undergraduate research experiences, a question that we commonly get is, with this many students, what is the quality of the experience that they actually get? Is it a genuine experience? And I think that one of the best answers to that is, I think that it is, because this is a team effort. So the way we do this is that the Hua Lab collaborates with Dr. George Meindl, who is the instructor on record. And so through the division of labor, we provide a lot of the research insight, the materials, and the organisms. Dr. Meindl focuses on the teaching the students, getting them up to speed, giving them the background, and he meets with them weekly to make sure that everybody's contributing to every part. And in this way, we try as hard as we can to give everybody that full experience. And so me being an ecologist and not an educational researcher, we're working on assessments for this. And so what we have done so far is just thinking a little bit using the data that we have. These are data from our student surveys, just thinking about whether they benefit in terms of interest in the topic. So we're looking at interest beginning of the course versus at the end of the course. In red is high interest, orange medium interest, green low interest. At the beginning of the course, it was pretty mixed. There were some that were really interested, some that were not interested at all. It just fit their schedule. By the end of the course, the vast majority of them reported that they had high interest in the topic, and importantly, none that were not interested or had low interest. So just one metric that this might be working in providing encouraging students' interest in a topic. In terms of the research that we do, we've run this class 5 times, and the first 3 have been published. The final 2, we're working on analyzing the data now. All of this to show that the research that they're doing, we think is research that can contribute to the scientific community, something that they really can be involved in. And some of this work, especially the invasive plant litter and metal work, I'll present tomorrow. And finally, what about the students? Many of these students have gone on, not all of them, but many of them have moved on to graduate programs all over the country, as well as we've been lucky to retain some of these students in our own program. So all in all, who we are as a lab, we are a research institution, and so our primary objective is research. But as I'm learning, opportunities continue to present themselves, and that has forced us to think a little bit more about the education side of things. And so we think about how we can use our research to inform education, but we're now seeing the reverse. Our educational efforts are now feeding back and providing funding for us to now do research that hopefully will continue this research education integration. So with that, we hope to contribute to science through our research, improve research communication, and create opportunities that will facilitate diversity, equity, and inclusion in our field. So that is the overview of the science communication education work that we've sort of done in my lab. I have many people to thank, because the way this works is I've had passionate students that have convinced me that this is the way, and in working together, I think this is how the cascade of their passion. So with that, I'd be happy. Hopefully I've left room for questions and plenty of time to discuss what is our role, what is your role as a communication, as an environmental communicator, and how do we balance our various efforts. Thank you.
Thank you, Jessica. And the way that we're going to do this is I ask you to use the chat feature to ask your questions, and then I'll just read them to Jessica so she doesn't have to to deal with too many other things. Glad to see the claps starting to show up. And so, yeah, if you have questions for Jessica, we have about 20 minutes. So or comments for that matter. And while people are typing or thinking, let me ask you, Jessica, for the undergraduate experience, those students, is this a course that's specifically for non-biology majors? Or so this is maybe their only exposure to this kind of work?
This is actually a plant ecology course. So it's housed in environmental science, but many biology students take the class.
Okay.
And we're lucky at Binghamton. There's the course-based undergraduate research experience starts as a freshman. And so they get that opportunity as a freshman. And if they miss that opportunity, they also can take later cures, such as this plant ecology course.
And how diverse is your university?
I think it's, I would say it's fairly diverse. I don't have the statistics on it. We are actually hoping to get that relatively soon, at least in our departments. We formed, there's a newly formed DEI committee. And so I hope to have that eventually, but it's not knowledge that I have off the top of my head.
I was asking because it looked, the photos, it looked certainly more diverse than Utah State University is. And so that gives you more opportunity perhaps to have influence than in some places. That doesn't mean that there aren't still ways to do it, but it does help. We do have a question about your elementary school program. Is that field trip an ongoing thing? And Rosemary also wants to know what grants you use to fund it.
Sure. So it is a summer program. So it is 100% run by the museum. They hire an environmental educator that we train, and this is this is why it works, and this is why we can bring in so many people, because we're leveraging their expertise in logistics and our expertise in just the information. And they run it in the summers, at least I should say our summers, the end of the school year for the students. In terms of funding, we got funding from the Schumann Foundation, which is a private foundation, and it was purely because they saw our work with the art. So this